Today, we will be continuing our biomechanical analysis of the front squat by Brandon, Tiffany, Jennifer, and Aaron. Last time, we looked at the muscles involved in both the descent and ascent phases and applied the concepts of linear and angular position and velocity and acceleration, as well as Newton's 3 laws of movement. Today, we will apply the concepts of torque, angular velocity, energy, work, and power to the front squat. Torque is defined as the magnitude of force causing the rotation of an object. The influence of gravity on each particle creates a huge number of individual torques. The distance between the muscle and the joint center is called the moment arm. The bigger the moment arm, the more torque can be generated about the joint for a given level of muscle force. Angular velocity is the rate of change in angular displacement. In other words, how fast an object is rotated and in which direction. The radius of gyration of the moment arm will affect the angular velocity. Angular velocity increases proportionally to torque and inversely to inertia. As the athlete begins to bend his knees, ankles, and hips in the descent of the squat, the resistance torque is greater than effort torque and results in downward movement of the bar and eccentric contractions. As the athlete straightens his legs, the effort torque is greater than resistance torque and results in concentric contractions and the lifting of the bar. Torque of the joints creates angular velocity about the hips, knees, and ankles as the athlete lowers the bar towards the ground. As the athlete straightens her legs and moves the bar upward, she works against the inertia of the weight to create angular velocity upwards. The radius of gyration of the weight being held and the athlete will affect the rate of angular velocity. Kinetic energy is the energy associated with motion, where potential energy is associated with position. Total energy is the combination of the two. Work is equal to force times distance, where power is equal to force times velocity. Energy. Once the weight is on the shoulders, there is potential energy. And as the athlete begins to squat, the potential energy is absorbed at a rate that causes the controlled descent. Then, the athlete must expel energy to continue moving the bar. When back front and front squat are compared, more energy is produced at the knee during front squat, where in back squat, more energy is produced at the hip and ankle. It was concluded that front squat provides a better muscular exercise than the back squat. Work. The deeper the squat, the more work that has to be done to complete the repetition. During the eccentric phase, gravity is performing work. Concentrically, the lifter is performing work to lift the bar. If the lifter pauses at the top or the bottom of the squat, work is zero. To be the most efficient, the bar should travel in a straight vertical line. Any horizontal movement will add to distance and increase work. Power. With a greater acceleration during the ascent phase, force is increased, which increases power. With a faster performed squat, there is greater muscle activation of the erector spinae, glute max and med, rectus and biceps femoris, adductor longus, and vastus lateralis compared to a slower speed. It was found that the back squat produces more power than the front squat because of bar stability, which leads to faster movements. Here are our references. Thank you for watching our presentation.